Okay, let us start our discussion today. Today we are going to talk about convolutional neural networks. This is discussed as part of Unit 3 of deep learning subject and very important concept in deep learning. So convolutional neural networks or CNN have become a very huge success in many of the computer vision tasks such as image classification, image recognition, or detection or segmentation. In all these things, CNNs have become highly successful. So let us try in this lecture, let us try to understand why these are called convolutions and what actually convolution is. Convolution is you have two mathematical functions. Uh, Let us say we have two functions, and what we mean by convolution is moving one function over the other. For example, I have a function like this. Then I have another function, let us say, which is something like this. Now, what I do is I will slowly move this function uh, over this red line, moving one over the other. This is known as convolution. To understand this, let us consider an example. For example, you're talking about time series data or a data where suppose you are talking about an aeroplane and you are taking sensor data from that based on its position. Now you are at position x2 and the previous positions are x1, x0. Let us say because each measurement is not very reliable, we will take average of all the previous, maybe 5 previous. So xt minus a, w minus a. W is the weightage of each one. So obviously the previous one will have more weightage than the very older ones. And this is the position and this is the weightage. Now see, in this example, I am borrowing the slides from NPTEL lectures by Mitesh Kapra. Now, if you see here, uh, this is X, these are the positions, and this is the weightage. So now wait, I am position this position. What I will do here, I will multiply W0 and this X, W minus 1 and this X, W minus 2. I will multiply all those values and add them and I will place it here. Next, what I will do, I will move this W filter one step ahead. Now, zero point 0.5 will be the weightage of 2.10. Zero point 0.4 will be the weightage of 1.90. So, what will happen? So, zero point 0.5 into 2.10 plus zero point 0.4 into 1.90, 0.04. That next, what will happen? Zero point 0.5 will be the weightage of 2.2 and you will fill this value. And this is how you will be moving one kernel over the other. This is one dimensional data. In two dimensional data, especially when we talk about image, we take an input image and we'll place a kernel over that image. For example, let me show you some demo here. So this is my input image, and in that I am placing a filter of 3 by 3, placing a filter of 3 by 3. See here, so this is the first one. I am placing a filter here, and maybe that filter may have certain values, something like 0, 1, 0, 2. So it would be better if I can stop this one, but I don't know. Yeah, you can see it better here. So what I'm doing, I'm moving one filter, one kernel over the other. Let me take a mathematical example. Suppose you have an image of maybe 5 by 5, 1, 2, 3, 4, and this is 3, 4. And I have a filter here, which is, let us say, 2 by 2 or 3 by 3 kernel. Now look at the terminology. This is 3 by 3. This is called input. This is the generally image data, a two-dimensional matrix. And this is known as kernel or filter. Now what we do is, I will place this kernel. For example, this kernel will have, let us say, 1, 0, 0, 0, 1, 0, 0, 0, 1. So I'll place my kernel here. Let us say here I have the value 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm placing, when I place my kernel here, what I will do, I will take element by element multiplication. 1 into 1 plus 2 into 0 plus 3 into 0 plus 4 into 0 plus 5 into 0, 5 into 1, sorry, plus 6 into 0. Then the third row, 7 into 0 plus 8 into 0 and 9 into 0. So this value we will place in a new matrix. So what is this value? Only diagonals will be 1, remaining all things will be 0. So it will be 1 plus 5 plus 9, 14 will come here. Similarly, then I'll keep my filter in this region. Again, the diagonal values will be preserved. And I will place my filter here. So what I'm doing, I'm convolving one over the other. This is known as convolution. And this output is known as feature map. So based on these different kernels, for example, you may have different types of kernels like, let us say this kernel, you can see all are ones. So what will happen? It will blur the image because what you are doing, you are multiplying each pixel with 1 and you are compressing that. And obviously, you know that when we do this operation, the output size will be reduced. That's why it is being blurred. So, and then you have another filter here. Middle pixel you are multiplying with 5, and all the remaining you are making 0 and -1. Obviously, middle pixel will be highlighted. That means it will result in sharpened image. And now you can see this here middle pixel is -8. That means it is being darkened and all the remaining pixels are same value. So it is known as edge detection. So only the edges will be found by this filter. So CNN, what it will do is it will learn these filters. That means each filter or each kernel, there are series of kernels will be used. Each kernel is used to extract a feature. So you will be using a bundle or a series of kernels for all the features. And good news is that we need not manually pick the kernels. CNN will learn the best kernels. Now let me show you a demo of this convolution. So this is how you will be moving it in different positions. You can understand it better by looking at this one. So this will, each value is projection of that filter. Now Deep Lizard website, they are giving a better way of understanding this. Now I can take different filters. Top edge filter, the this will be -1. That means they will be darkened, and middle will be 1 and bottom will be 0. That is top edge filter. You can have bottom edge filter. You can have left edge, right edge filters. So let me do this one. So this is the filter. Right side is -1 and this will be 1 and this will be 0. That means it will darken these right edges and it will make this one as same because you are multiplying with 1. So first the filter is placed here. All these are zeros and I have taken the number. This is MNIST database, a database of all the handwritten numbers from 0 to 9. Let us say I'm taking 4. So all these are, you can see here, so the filter is slowly moving because there is no value, all are zeros, your output is also 0. Now then the second row, and as it does, what will happen? It is detecting the right edges. You can see here. You can see that it is detecting all the right edges. That is one filter. Now let me play the same thing with top edge filter. When you take top edge, this horizontal edges will be highlighted. Now let us see. You can see this horizontal edges are highlighted. Similarly, You can take left edge filter, which will highlight this part. So this is known as convolution. So what is the good news? What is the good news? I told you that you need not manually pick which. You need not bother about which filter should be applied, which filter should be considered, because your uh, CNN will automatically